in a time of social media. So before we all start off, everybody a big smile, big thumbs up, and I have to start off with a selfie, otherwise it just wouldn't be quite right. Hey, my name's Brett Tax. I'm from the US, if you haven't figured out by my funny accent. And I've already talked to several of you, and you know me from adventure riding, doing the Moto Trek series. However, my main job is actually training street riders, working with special ops in the States, and also working with police and instructors. So that's actually what I'm going to be discussing this morning. My intent and what I'm going to send you off with today is something that you can use today. I want to give you something tangible that you can go out and put use to, but also I want you to think a little bit differently, and hopefully I'm going to open you up to a couple of new ways of thinking and go from there. I'm going to start with just talking about what we think about riding in general, and we're here as a safety event. And when we say, gosh, you know, what's the most dangerous place that I'm going to be as a motorcycle? What's the greatest risk? The question is this a myth or is this a fact? Those of you think this is a fact, guess what? This is going to be interactive now. Show me with a show of hands, who says this is a fact? We got to worry about the right-hand turning cars. How many of you say it's not the cars? Hands up. How many of you are too embarrassed to raise your hands? Raise your hands. Excellent. All right. So it does turn out that those of you that were believing that, yes, there are other things that we should be concerned about, that's true. The greatest hazard on the road is not that car that pulls out in front of us. That's actually a myth. We hear about it more frequently, so that stands out in our mind. In reality, what we find out is that we do a very poor job of staying in our lane. And now these statistics here are actually from my home state in Washington. We actually sit at the same latitude. We're in a subduction zone. We've got lots of mountains. It turns out the numbers in New Zealand are almost identical. It turns out we all like to die in the same places. 72% of our motorcycle fatalities were in curves with no other vehicle involved. Nothing. Which means whether it was gravel or air pressure or mechanical failure, which almost none of them are, that still falls back on us as riders. When we looked at the multi-vehicle accidents, we found almost a third of those were us running out of our lane and then involving another vehicle. Here's the good news. We do it to ourselves, which means you guys have complete and entire control over that outcome. And so there really is two different ways that we end up dying. One is we run out of our lane. The other one is we run into cars. Just a complete failure to stop. And I'm not talking about cars pulling out in front of us and us braking. I'm talking about running into the back of cars or running into cars that we should have already seen. So those are the two things, and I'm going to cover those two subjects real quick as we go through and give you some things to work with. When we looked at drivers or riders and we interviewed riders and said, let's figure out who actually assigns value to who. And we went, all right, so is it the car driver who's distracted? Is it the motorcyclist who's distracted? Is it on the cell phone? Is it drinking? As we went through that, it was an interesting pattern. And when I put all those together and just went them and us, so I took all the little complaints out, just one or the other, and started looking at the experience of the riders. One of the trends I found out is those riders down here with 0 to 3 years experience, about 53% of the accidents, he said, that belonged to the other guy. The more experience we ended up with, guys with 11 plus years, they were saying as much as 69% is the other guy. Turns out the more experience you have, the more inclined you are to blame the other guy. And that kind of plays out kind of interesting. Now, when we looked at the actual incident reports, fatalities, and they said, okay, well, who was actually at fault? Those numbers are far less. 18% of the multi-vehicle fatalities in our state were the fault of the other driver. The state just south of us, very similar to what we have here, we're at 20%. Peter, New Zealand police officer, turns out the numbers he's finding are very similar to what we have. Again, a very consistent pattern when we start looking at westernized nations on fault and understanding of belief. The question I would pose, and you might be asking, is why are we talking about fatalities? Why am I addressing these topics if my goal is to make you better riders? And the answer is, if you don't understand where the problem is, you can't address the problem. And once we understand it's us, and we don't corner very well, and we don't stop very well, then we can move into those different aspects of riding. Who stops faster? Cars or bikes? Who wins for the bikes? Bikes stop faster? Cars stop faster? Don't have a clue? All right, a couple there. Perfect. And this is actually really nice. This is not average. Most of the time we still have a lot of myth about the cars versus bikes. And it turns out that most of you were correct. The cars are stopping significantly better. If we look at the high-end vehicles here, we're looking like a Corvette Stingray, a 918 Porsche. These are stopping from basically 100K down, 100K to zero in 28 meters for the Stingray. The motorcycles are stopping in 34, almost 35. That's a big difference in stopping distance. The one thing you may notice here, if you can't read the little eye chart, is those two top bikes there, one's a Harley and one's a Ducati. One's a sport bike, one's a cruiser. Turns out their stopping is the same. That's something that we don't always realize, but here's what we haven't really put our minds to. The sport bikes don't build brakes to stop. They build brakes to slow, and slow repeatedly from very high speeds. That's what high-performing braking systems are all about. Harleys stop really well once. And once we start understanding what the purpose of this is, we start realizing that our limitations are more the rider than it is the cars themselves. The other one to point out down here is this is a Town & Country. It's a minivan down on the bottom. We all know that's a high-performance minivan. The worst performing one I put down here, also we have a Chevy Sonic. That's always a high-performing vehicle. These stops in 38 meters from 100K. That's almost a 1G stop, 0.96. Now when I say G's, to explain what this means, we take the vehicle and we find out how much time and distance it takes, and we calculate that into an average deceleration rate, and that's calculated as a G stop. And what that means is some of you may actually hit threshold on your braking. You get a little stoppy at the end, or maybe a little front wheel skid. But if it takes you a long time to get to threshold, that overall G stop will be very poor. Right, so it's not just about how well you stop, it's how quickly you get to that limit and how well you can track that all the way in. Looking at kind of some comparisons, these are just bikes and cars that are matched up. These all have the same stopping ability. So of course a Hayabusa, we always associate that with something like a Chevy Silverado pickup truck. They actually have the same braking numbers. The vehicles aren't that much different. Now when you start getting away from the high-end cars and start coming to the average stuff on the street, our bikes and those cars are stopping about the same distance. The difference is my daughter can text, do her makeup, and eat lunch, and pull nearly a 1G stop in a minivan every time. We don't do so well. I did 11 years, these numbers come from an 11-year project I did with the US Special Ops guys, and I'm not actually teaching them. I do some downrange training, but this was on-road stuff. This was to keep them alive on the street is what it was all about. And the reason I mentioned this target audience is because they're kind of the ideal. They should be the ones that perform the best. These are not young guys. These are the special operators. These guys are in their 30s and 40s. They have a lot of years of experience. They all have to have training. They're on their own motorcycles and they're riding during the riding season. Kind of a perfect scenario. They ended up stopping around a 0.7 G stop on average. So wasting about 30%. That's the same number I find on civilians, trained or untrained. That's the same number that Peter uses on a lot of his information when he does accident research. We waste about 30% of our braking. This is why we get ourselves in trouble. It's not because the bikes can't do it, it's because we won't do it. And I'm going to tell you why you do that, and I'm going to give you some ideas on how to solve that. But recognizing these issues and challenges is kind of where I want to start. When we looked and just took out the ABS bikes, riders did slightly better, about 0.05 better. So just a very marginal improvement. If you think about ABS, one of these is ABS equipped, the other one is not. And when we take a look at those ABS and non-ABS dogs or bikes, what you'll find is those braking numbers are almost identical. And all these are going to be somewhere near or just over 1G. Remember, as riders, we're only stopping around 0.7 to 0.75. So we're wasting 25 to 30% of our braking. These numbers are from 2013, 2014. In 2016, those ABS systems evolved enough that you're not seeing professional riders match those first, second, sometimes 3 or 4 runs. And some of the bikes, they can't beat the ABS. Technology has moved a long ways. So having those on the bike or having those safety systems really becomes a huge advantage. Those in the adventure world, I know several of you are here because we've chatted already. We see off-road ABS now, and that wasn't something that you would have seen, back in the mid-2000s or even, in that when ABS was still coming into kind of a modern era there. Trust the system will probably do better. So number 1, we run into stuff. Number 2 is cornering. How many of you all know what trail braking is? How many of you have been told don't brake in a corner? How many of you ever used your brakes in the corner and are here to talk about it today? Absolutely, every one of us. Turns out that we brake into corners naturally. I'm going to define what trail braking is. If you go into the corner and then you go for the brakes because you miscalculated the corner, that is called oh shit braking. That is not trail braking.